Welcome to NASA Doesn't Know What the Hell They're Saying on Social Media, and whomever's on social media should be fired, starring Kevin Connor criticizing NASA Webb's telescopes, uh, social media BS that's right here. Before I begin, I want to say that the Webb telescope is an amazing technological feat. It has provided invaluable information that has just done amazing things in terms of our understanding for all sorts of levels of science, mathematical, metallurgical. Just building something like this telescope required new inventive ways, new technologies. And then we get images that we can examine. And that's absolutely fantastic. What isn't fantastic is when a moron behind a desk looks at two images and doesn't understand how infrared or light waves work. A Titanic success. Oh, cute pun. Actually, that is a good pun. I like that. I like that pun. Here is Webb's first look at Saturn's largest moon, Titan. I like Titan. Titan's pretty cool. By the way, we should start changing how we describe moons and planets. Just my thought. Because Titan has a dense atmosphere, its surface is hidden in visible light. Enter Webb's infrared eye, which captured clouds as well as bright and dark patches on its surface. It did nothing of the sort! Nothing of the sort! That's not how infrared works. Infrared is a method of detecting wavelengths that are beyond our normal visibility, range of visibility, right? And typically infrared can only really detect, like heat signatures. Infrared is pretty good with because heat does change energy and light, and how it views and all sorts of stuff. But usually you need to have a proper contrast. And so it tends to focus on brighter sources of light. You know, like white light is very, very bright. White light is white because it contains a lot of white, a lot of light wavelengths. The more color you get involved, with the image that infrared examines, the less possibility for infrared, the more muddied the image is, and the less valuable it is. What this infrared picture accomplished was evaluating the light sources visible in the color image. That's what it did. It didn't detect anything beneath the surface of the clouds. See, they even say this in their own tweet. Because Titan has a dense atmosphere, its surface is hidden in visible light. Visible light and invisible light is still light. Light particles are light particles. Light waves are light waves. They're the same basic atomic construct that's changed by the speed of and the form of the light wave. And to all those people out there that say light travels at the same exact speed, you're an idiot. Light particles may travel at the same speed, but light waves determine how quickly the information goes from point A to point B. That's why certain light waves are better suited for things like fiber optics than others. So what you really have here is the infrared was separating the light information in its system. And you can actually do that in Photoshop. So there's so very little information in terms of the infrared wavelengths that all you have here is a basic adjustment of color removal. Since infrared is still light, and light can't pass through those clouds, we have to assume that everything in these clouds, well, first of all, we need to, yeah, we need to readjust the color, right? So the color, we're going to remove it. Let's see here. I could adjust it all down. There we go. There we go. That's basically what it does. Removes the color. Adjusts it all. There's a tint. Could have fun with it. It's basically what it does. I'll go ahead and auto it, right? Default. Then what else do you do? Well, infrared, in order for it to work and separate the wavelengths, it adjusts the brightness and the contrast, essentially, of the information that's given. That's basically what it's doing. Usually, you get when you mess with infrared, you have to change how much is being adjusted. I'll give a guess. I'll say it's 50% both ways. That's minus 75 plus 50. Holy crap. That's exactly what the infrared processing did. Now let's evaluate this further. Let's go ahead and look at the color information, because color is basically an antithetical toward infrared. So this is color. You got a little dip there. It's color, 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 color. In fact, down here you have no color right there. Let's see here. Yeah, more light there. Sorry, doing this on the mouse is a little bit difficult. There. See a little dip there where the color kind of forms in? Let's move this over here. Hey, that's pretty damn close. Put it over here. Holy crap. Let's go ahead and just see now, because this is colored information and the infrared is not trained to see color, what it sees is a lot of nothing. One huge giant blotch. Look at that. It looks remarkably similar. I'm using this as a visual demonstration to say that NASA doesn't know how infrared works, apparently. At least not the person on the social media. How infrared works is exactly how I said it works. It tries to separate the wavelengths. In order to separate the wavelengths, you often remove the contrast. You create your own contrast. The red is its own creation. The color for the red is its own creation. It's as if I would go in and I would change the color tone, adjustments, color, balance, color mixture, auto color, auto tone, stuff like that. Colorize. There. Put it all up there. Highlights, shadows. That's why you get red color with infrared. It's basically what it does. There's no color, there's only color information here, which means that the infrared eye can't see through it. So it's a giant blob of non-information. That's what this is. This digitized section right here is a lack of information for the infrared. You can barely see some things. If you stare at it, you think that you're seeing spots, but really is your eyes are playing tricks on you. But you can see the kind of digitization and the mass of nothingness, the mass of blackness which is in there. That's because the infrared eye can't distinguish what's in there. So NASA thinks that the infrared eye can see beneath the clouds. It can't. What it actually sees is what's right there on the surface of the clouds. This is here, which is here. Cloud B is here, which is here. Cloud A, you can still see it, although there are things covering it up right there. Remember, that is right here. This is color information, and the light can't, the infrared eye can't determine what color is. So that's really color information, so there we go. And it even has the little dip here. You see that little dip? That little dip is actually here too, because if you zoom in, you see that there's a lot of color information that goes down in a V. Right there. It goes kind of like this, right? That's what the infrared eye is seeing. So the infrared eye is not seeing through the clouds or the surface of Titan. The infrared eye is seeing the atmosphere of Titan and the infrared light that's passing through the atmosphere. One of the cool things about planets, a lot of people say, why do planets have a weird glow to them? Why is there like a ring around a planetary body? Because you see there's like a ring here around the edge and a funny glow. And in all these images, there's a ring and a funny glow. Because the atmosphere is layered. And when you have a high density photo, this one is not high density, but you can still see the layers here if I zoom in. When you use an infrared eye, it picks up the layers as having less of the infrared wavelengths than elsewhere. But the gravity of the planet causes that light to bend. And in addition to that light bending, because light still has mass, in addition to light bending, the light is also refracted through the atmosphere. And these bands in the atmosphere are curved. So the light refracts in a curved way. So that's why you get this cool little halo and these little spots when you look at planets. That's why when artists draw planets, if they don't take into account for the planet being round and you don't actually kind of make it look like your color and your light bends as if it's on a sphere, then it looks flat. It looks like a disc. But this is not a flat planet, unlike our own. I'm just kidding. Just kidding, guys. This is not, our planet's not flat either. But the curvature is what gives you the refraction of this energy, of this heat, of this light, of the infrared. That's why you get these beautiful, beautiful little shaded spots. Cloud B, cloud is a mass, and it's lit, and it's refracting everywhere. You see the depth of cloud B. It's probably a cumulus cloud. In addition to the strata, you see that it kind of rolls along with the surface of the atmosphere, but it's also kind of focused. It's probably cumulus with a strata or something like that. This down here, it's a huge, huge, thick, nicely refractive, light-colored cloud. You know, light gases, probably nitrogen, oxygen, hydrogen, all the good gases that we have here on Earth. In addition to all of the crazy lethal gases, potentially lethal gases, give it nice color to it. So that's what you're really seeing. You're seeing the clouds and the light being refracted through the clouds. You're not seeing the surface of Titan. And that's because infrared can't see beneath a thick cloud cover that also prevents you from seeing any spectrum of light. Now, if it were detecting heat, now that would be even more difficult, because you could only do that at certain ranges. Otherwise, the heat turns into one big blob. Because heat is all over the place. Heat are particles that like to move all over the place. Like on Earth, you can use LiDAR and stuff to detect ground temperatures and see what's going on where. Now, that actually is sort of like X-ray vision. But you can't do that through the dead of space with a planet that's thousands of miles away, hundreds of thousands of miles away, astronomical units away from our planet, because heat does not travel like that far, that cohesively. You just get blobs, like what you have over here. You have a giant blob of information. So no, you're not seeing beneath the surface beneath the atmosphere to the surface of the planet. I can't believe that NASA actually said that in their tweet. NASA, you could do better, and why don't you hire me? I am clearly more qualified than the individual who posted that tweet or gave authorization for it. And if your engineers think that this is how infrared works at a distance, that you can see through clouds, I sincerely hope that they're watching this video and then they go to something like Bill Nye's site or any site that instructs you on how infrared actually works. Now, I gave you guys like a really basic overview. I'm sure you could have it explained in far more technical and more specific terms. But the rule of thumb for infrared is that it has to be a source of light to begin with, or energy, I should say energy, because even heat gives off forms of light that we can't really see with our naked eye most of the time, although I'm sure some of you have seen heat rising, warping through the atmosphere, right, on a very hot day. So infrared needs sources to distinguish one from another. It doesn't like color. This is color, right? Oh, my friend's playing Dota. So this is color information. It's not going to pay attention to color information. Color doesn't give off special infrared, right? It's looking at the white spots, which is heavily sourced, dense forms of light, right? And it's telling you, okay, these areas, which are really, really bright, they've got infrared in them. These areas, which have color, it's kind of dark to me. I can't see anything there. That's what it's saying. It's not saying anything else. It's not looking underneath the clouds. It doesn't have X-ray vision. I do support the telescope, though, and I think it's an amazing, amazing work of technology.